All right, hello everyone. So here's your quick little homework for tonight. We're just going to quickly summarize slash review what we've been doing both Tuesday and today in class. So in case you missed something or you're a little unclear, we can go over that quickly. All right, so two of the different topics we talked about today and Tuesday were quadratics as well as exponential functions. So a couple of things that we need to recognize when we're talking about quadratic functions is, first off, what is the shape of the graph? Is it positive or negative? Lead coefficient, the structure of the function, and then what happens in the table. All right. So let's make that a full screen. That might make life easier. No, I lied. All right. So just below here, I have two different examples of quadratic functions. I've got a positive lead coefficient quadratic on the left, and I've got a quadratic with a negative lead coefficient on the right. Well, just a reminder, what I mean by lead coefficients is simply the number that's attached to my x squared. All right. When we're talking about quadratic functions, we care about seeing x squared being the main variable that we see. That's what we call the highest degree. So in this particular example right here, we see that it's a positive 2 attached to my x squared. So if the 2 is positive, I'm going to see a smiley face. It's going to be positive. Whereas if I've got a negative 2, let's change that color. If I have a negative 2, I've got a negative quadratic, so it's going to be a frowny face. It's going to be sad. So the main thing to recognize is the shape of a quadratic. Really, it's called a parabola. And if it's positive or negative, we'll determine if it faces upward, if it's concave up or concave down. All right, the structure of the function algebraically, the main thing you want to look for is, do I see x squared? All right, do I see an x squared? And you want to make sure that x squared, the highest possible exponent is a 2. So if I saw like x cubed plus x squared, that's no longer a quadratic. Okay, keep that in mind. We need to have x squared be the, that's not the eraser. We need it to be the highest exponent is the squared. Okay. And if I'm going too fast, please be sure to come back and revisit some of these points. Looking at these functions from the table, one thing you'll notice is that we have something called a vertex, or kind of like a turning point, where the values from one side are going to go down and one side of the values are going to go up. It's like a mirror reflection. So if I were to kind of make my reflection right over here, after I pass this turning point down over here, it's 0, 1. On the left-hand side and the right-hand side, I see the same exact thing. All right, and same idea over here. Here's my turning point. Here I'm going up towards 1, and here I'm going down towards negative infinity. All right, so the main idea that we want to talk about here, besides just reviewing this stuff, is just quickly touching upon the domain and range. So domain is my x values, the range is my y values. So it's my x, here's my y. So what x values can I plug in here? When we're looking at quadratics, we can look at all x values. We can look at x when it's a really negative number. I can still plug that in. I can plug in x when it's a really positive number, right? These quadratics don't just stop, they keep going. So my domain for x is going to be all real numbers. Okay, so it's all possible x values. Any number I can think of, I can plug it in. The range, however, we want to look from least to greatest. So from least to greatest, what's the smallest y value I see? Well, the smallest y value is at my vertex right here. So the smallest y value is positive 1. But then every other y value is above it. So it's going to be everything that is greater than or equal to 1. So y is going to be greater than or equal to 1. If we look at our negative one, Domain is still the same. It's going to be all real numbers. So any number we could talk about. And then my range is going to be when y is less than or equal to 1, right? It's all the values of y that are less than 1. All right, so that's talking about domain and range. Now, if we look at exponential functions, we want to make sure we can recognize the shape. So it's starting slow and going fast, or it's starting fast and ending slow, right? Little bit, and then it explodes, or it's coming down really fast and then slows down towards the end. The structure of it algebraically, you always want to look for x in the exponent. And then on the table, we talked about this, we see a pattern, right? We're actually going to multiply by the same number every time. So here, to get from 0.25 to 0.5, I get times 2. Once again, times 2, and so on and so forth. So I see a pattern of multiplication. Here, to get from 4 to 2, I've got to divide by 2, or times 1/2. And I do it again, times 1/2, times 1/2. So we notice a pattern of multiplication. Once again, looking at domain, it's all the x values I can plug in. There's nowhere on this function that I can't plug in an x. And there's the bell. Fantastic. So I can once again look at all real numbers. Same is going to be here. And then last but not least is the range. If we were to plug this into our graphing calculators, we would see that my y values, they get closer and closer and closer to 0 without ever touching it. So y is always greater than 0. And the same thing over here. 0 is less than y. Okay. So you guys are going to take a moment now. I'm so sorry about all of these announcements going on in the background. I'm going to stop recording now, and you guys are going to answer some questions.